Hi, I'm Keith Glassnap, and I'm one of the mentors for the Dirty Mechanics team, FRC team 3932. And today we're going to be reviewing the different control elements that we use in FRC robots. Turns out we'll go into what each of the elements do, a quick overview of what that element does, some of its specifications, and in particular, how to wire it up. So by the time you're done with this, you should be able to wire up a FRC-based robot. Okay, and that's the whole purpose. And to understand a little bit about the different elements of FRC. And let's see, why did not that work? Okay. The RoboRio is essentially the brains of our robot. Okay, essentially where the high-level software runs that goes and controls the robot. And basically we will go into what all of the little connections are as we go through it. But FRC, it's the brains, and you can program the RoboRio in a number of different languages. You can do it in C++, Python, and Java. We in particular use Java in our team, but we could use other languages if we chose to. Okay, it's designed specifically for FIRST. It's created by a company called National Instruments, who does a lot of different real-time elements for different kinds of industrial uses. But they made the thing called RoboRio for FRC. At some point, probably, hopefully in 2022, but definitely by 2023, they're going to come out with a new RoboRio that has more memory and is faster, but it's going to essentially be the same basic functionality. But the beauty is all the software that we've written over the years will be compatible with not only the existing RoboRio, but the new RoboRio as well. So they're trying to maintain backward compatibility for us. Okay, it has a number of ports in it that we can use. We can use something called I2C or I2C, integrated circuits. It's an interface that's used in a lot of different things today. In particular, it's used for a lot of different sensors. Like you can get gyroscopes, you can get distance sensor, you can get temperature sensors, barometer sensors. Pretty much if they have a sensor for it, you can get it. And so we use I2C when we want to connect to things like the lidars and some of more advanced distance sensors. We also have something called SPI, Serial Peripheral Interface. Again, we have not used that particular interface, but it's available if we want to. The beauty of I2C, it's basically a two-wire interface, basically a clock and a data interface, whereas SPI requires, again, clock and data, or in fact, two data interfaces as well as a control lead. So it's a little bit more complex to get it to work. They also have something called RS-232 that we can use if we want to for things like low-level debugging, but typically we have not used it. It's got a USB interface. It's got an Ethernet interface. It's got something called the pulse width modulation interface that allows us to control some different kinds of sensors and things of that nature. We can not only read pulse width modulation, but send it. We have ports to connect relays, like Mr. Rick talked about in his class, to go and allow us to control higher current functions. Like the controller itself allows you to control different kinds of LEDs. You can read buttons. They do have an onboard accelerometer, but it's not very good. And it has a port where you can plug in bigger electronic boards, like things called the NavX, which we use to really go and get our navigation information, in particular the yaw. Okay, it's built with something called the Cortex A9 processor, and it has what's called FPGA in it. And FPGAs essentially allow you to write programs to control hardware. Okay, you basically write software that basically controls gates in the FPGA, so you can really go and make fancy things if you want. And one of the things, for example, they added this year in the FPGA was the ability to control LED ring or LED strings. So you have LED strings that you can turn on different kinds of colors and control each one. There's a ton of information on the internet about the RoboRio. For example, you can go to the RoboRio user manual. Okay, and it goes into everything you ever want to know about the RoboRio. Okay, so it gives you all sorts of data you can use to go and learn more about it if you want. Similarly, there's technical specs that that go into, again, some of the more strange information about how much voltage and how much current and what the different interfaces are from an electrical perspective. All right. One of the things we must do every year is we have to what's called image the RoboRio, and there's a special tool to do that, and that tool is documented here. That goes and tells you how to image the RoboRio. That's something we have to do once every year. Okay. So let's go through how we connect it. So the first thing is we power it via this little connector here. I don't really like the symbols there, but V means the positive voltage and C means the ground. So we connect this up to what's called the power distribution panel, and we'll learn a little bit about that in a minute. And we protect the RoboRio with a 10 amp fuse. Okay. And again, in our world and most electronics, red is used for the positive voltage and black is used for the negative voltage. And if you connect the RoboRio backwards, you will probably destroy it, and it's a $450 unit, so you don't want to go and screw that up. So anytime you wire up a RoboRio, check with the mentor before you power it up, just to make sure that it's wired correctly. That's very important. The CAN bus here, I don't know if you can see my my cursor, but the CAN bus essentially is a set of a bus that's a two-wire bus that's daisy chained to most of the other control elements that we talk about. And basically the CAN bus is used in a lot of different things. It's an industry standard. It's used in your car. And again, we've already talked about I2C. That's controlled right here. And here it happens to have 4 wires. Turns out that this typical standard is a power lead, a ground lead, and a clock lead and a data lead. Ethernet port. That's not shown on this picture very nicely, but that's right here. And that allows you to connect up to the Wi-Fi modem or a Wi-Fi or a hub. That's basically how the driver station communicates with the RoboRio through the Ethernet port. Okay. Then there is digital section, digital I/O. So basically, if you notice here, there's a ground, a power, and the signal. And you can use these to control things that require 5 volts. You can either control this input or you can read from this input. And so these are things you can use if we need to connect up certain kinds of digital devices to to the robot. We've used it primarily as we would put jumpers on these ports here to basically use it to figure out what type of robot. So our software typically has been capable of supporting many different kinds of robots, like the minis, the mini V2, the big robots, different years. And by putting jumper wires on here, the software in the RoboRio is able to read those jumpers and then determine how to configure the rest of the robot. And again, here's the PWM for controlling certain kinds of sensors. We can use that to control, there's distance sensors we can use, or in fact, we can use it to control motors that are controlled by pulse width modulation. There's things here we can use to control relays. I think this is how we connected up the relay to control the LED ring. You can also have analog inputs that you can read the value of, let's say, a potentiometer, or in fact, some kinds of sensors that provide an analog voltage. There's also the RSL, that's a robot signal light. That basically indicates that the robot is active or inactive as long as the unit is, there's power applied. Up here, basically the RSL is constant, but if we've enabled the robot, then the RSL light will blink. If you see up here, this is the SPI, indicating there's a lot of wires in there, so that's why we don't use it, because it's pretty complex. So Ethernet, this USB port, the square one we call it, that's used when we want to connect the robot to the drive station in the pits, because in the pits we're not allowed to use Wi-Fi. So basically this allows us to program the robot or control the robot. So it acts just like this Ethernet connection from the driver station perspective. And these here are two USB ports that allow us to basically connect up USB devices. For example, we've typically used that to connect the Raspberry Pi to the robot. We use these here to connect the Pi to the robot, or at least we could, or we use this to connect cameras and things of that nature as well. Okay, so we talked about Ethernet, we talked about the digital, we talked about the analog, PWM. So for example, if we ever put a servo on, PWM is used for servos, exactly the same kind of signal that you use on the robot car to control the servo that controls the ultrasonic sensor to turn it right and left. And you can also connect up certain kinds of motors to the relay port, but the only thing you can do then with those motors is go forward, or if you use two of the ports, you can go forward or you can go backwards. But typically we control motors over the CAN bus, and we'll learn about that as we go into it a little bit more. Okay, I think we've talked about this, the rectangular connections, the USB connections, the 34-pin connector, that's this thing right here. That connects up to what we call the NavX. Okay, that's the gyroscope robot signal light. Like we said, it flashes when the robot's enabled and when the motors are energized. The serial SPI bus, but again, like I said, we've never used that because it's pretty complicated. And if we ever need to do some low-level software debugging, we could use the RS-232 interface. Okay, so basically that is the RoboRio. So that's the brains of the robot. And again, that's where most of the software runs that controls the robot. And later, as we go into it, we'll learn about where some other software is on the robot. But typically, that's where 90% of the software changes occur. Okay, so now we're going into the different parts. We have what's called a circuit breaker. And basically the circuit breaker, basically, if there's too much current, and in fact, if there's over 120 amps flowing through these wires, the circuit breaker will open and protect the remaining hardware from any kind of damage. And we also use the circuit breaker to turn the robot off and on, okay? And so a lot of you have been pushing that button a lot. The gauge of the wire that we use to build up the wiring on the robot is very important. 12 gauge is pretty thick wire, and that's represented by these wires here. And we have to use 12 gauge for connecting power. So one of these wires goes to the battery, and one of these wires will go to the power distribution frame. So again, if there's too much current flowing through, basically the circuit breaker will pop and prevent damage. When you're wiring up the robot, make sure there's good electrical contact. In fact, one of the problems we had with the robot this year, or at least a year ago when we were preparing for competition, is someone had put heat shrink on the wire. And in fact, the heat shrink went all the way to the terminal here. And essentially what happened was that was causing a very, very weak electrical connection. And there's a lot of current that flows through here. And given the connection was weak, essentially made the robot do all sorts of strange things. And finally, we thought the batteries are bad, but in fact, the batteries weren't bad. So after we debugged it, then the robot started to work much, much better. So again, it's very, very important that the wires have good electrical connections. Okay, the next major element is what's called the power distribution panel. And that essentially controls the distribution of power to the robot. Essentially, the wires from the battery, the ground wire, connects up to the negative side here. And inside here, there's a connector again, that again, like I said, we have to make sure that's a very, very good connection, because if it's not, the robot's not going to work well. And on this side, we connect it to the positive lead. And so the positive lead will go to this, this wire will go to the circuit breaker. And again, the other side of the circuit breaker goes to the battery connection. Okay. Basically, then what this power distribution panel has in it is all sorts of connections then that we use to connect up to the motors in the robot. These are for motors, typically, these bigger connections. Particularly the drive motors and any kind of motor that requires a lot of drive power will use one of these connections. And things lower power devices like the Raspberry Pi, some of the other controllers, etc. We use these, so we use these for lower power connectors. And essentially we plug in to these little places here, fuses that basically act very similar to the circuit breaker, but the kinds of fuses that we use here are basically service fuses that if they have too much current going through them, they will open and protect the unit. But if the current then drops down after a while, that particular fuse will restore itself. So we very rarely have to change these fuses once we install them. So again, we also have on here, we connect up I forget what we connect up down here, but we connect up, we can connect up some lower current devices here. Typically, I think one of the things we've wired up here are the voltage regulation modules. The other neat thing about the power distribution module is it connects to the CAN bus. And typically it's the end of the CAN bus. So the CAN bus, like I said, will go from the RoboRio to each of the motor controllers, and then any of the devices that need CAN, for example, like the peripheral control module, will all connect in. So basically, the CAN bus finally terminates here, and you can put on what's here called a termination resistor. The CAN bus has to have a termination resistor to make it work correctly, electrically correct. Okay, so it has 8 high-powered channels up to 40 amps. We have 8 20 amp or 30 amp circuits, and we have some more 20 amp circuits, as well as another 10 amp. Then these 10 amp and low power 20 amps are back here. But so that's basically the unit that distributes the power to all of the other units in the robot. Okay. The next unit that we have in the robot that's, again, fairly important is the PCM, or Pneumatic Control Module. And basically, this unit connects up to the power, again, black for ground, red for the positive side of the voltage. And basically what this does, this goes and controls the compressor, the air compressor that we use for any pneumatic element on the robot. So the compressor gets wired up to here. And then if you remember, when the pressure gets to a certain level, the compressor will stop. And that's controlled here by the pressure switch. Okay. And so you wire the pressure switch up to these 2 points and the compressor up to these 2 points. And that basically then will run the compressor for the robot. And again, we connect to the CAN bus. And that then allows us to sense the status of the compressor, but it also allows us to control these channels here. And these channels here, essentially we use to control the pneumatic solenoids on the cylinder, or the pneumatic switches that we use to control the pneumatic elements of the robot. In fact, on the robot, the big robot we currently have, we have 2 PCMs because we needed more than 8 channels to control all of the pneumatics. Typically, each pneumatic cylinder requires 2 channels, one to control the in and one to control the out. And so again, this is a very, very important element. Again, you can drive some LED rings as well with this, but the net result is you can't power more than 500 milliamps of power from this particular unit, otherwise it will not work correctly. Okay, and we always use the 12 volt setting. You can run it for 24 volts. Some people who've used the pneumatic control module in the past have used it for 24 volts, but our team always uses the 12 volt. And again, just like every other module, you can come here and you can see much more details about it, where to buy it. It's, again, a fairly expensive module. Okay, and somewhere here, you can get information about it. Okay, I'm not sure where it is, but there's a better spec sheet for it. And so if you want to go and get more information, oh, there it is. Yeah. So it'll tell you a lot of information about the pneumatic control module. Okay, but like we said, we use this to connect to the power distribution panel and the air compressor and the CAN bus and the pressure switch. So real quick, some code that used to control the PCM. It's pretty simple. basically you define an object called solenoid, and you call the solenoid class, and you specify two parameters: the ID of the particular unit. Again, on a CAN bus, every device has an ID. And so the PCM will have an ID. And in fact, each PCM that connects to the CAN bus will have a different ID. So you can control each of the solenoids. And then you specify the channel number, i.e. the channel numbers 0 to 7, which represents these little particular numbers here. And the nice thing about it here is there's a little LED down here that allows you to see if that particular channel is energized. And when it's energized, it provides 12 volts to whatever's connected to that. So for example, so using this line of code, you essentially create the solenoid, okay? Or the software to control the solenoid. Then by using solenoid.get, you can get the current value of that particular channel. And that's either going to be a true or false. Or you can set the value of the solenoid, which is either true or false as well. So true means on and false means off. So it's pretty simple to control it. One interesting point, if you're controlling a pneumatic, you have to pulse it, i.e. turn it on for about 100 milliseconds and then turn it off. Because if you you cannot keep the pneumatic on for more than 100 milliseconds. Otherwise it will not operate correctly. So to operate the solenoid, let's say you want to push it out, you pulse the out wire. And if you want to pull it back in, you pulse the in wire. Okay. All right. Oh my, where are we? Okay, the next module is called the voltage regulator module. And again, we use this if we want to give another unit on the robot some clean power. So for example, if you have a 12-volt device that you have to power, or a 5-volt device you have to power, like the Raspberry Pi, you can use this device here to provide a nice voltage for the that particular unit. The beauty of this particular unit, it's got what's called regulators inside for the 5-volt and 12-volt. It's got not only boost, but buck. So the net result is the 12 volts here will continue to provide 12 volts even if the input has dropped below 12 volts. In fact, it will provide 12 volts as long as the battery voltage is 5 volts. It also has fuses inside. Again, they use a different kind of fuse called the PTC. Essentially, basically, if the PTC starts to carry too much current, i.e. if it exceeds 2 amps or 500 milliamps for these connections, it will open up. And then again, after a period of time, after it cools down, it will close again and make the connection. And if it's again carrying still too much current, it will open up again. So it kind of is used to protect units that are downstream from this. And again, you can see the status of the 5 volts and the 12 volts. So if the 12 volt fuses blows, this will go out, for example, this LED here. Okay, we're getting near the end. The next thing is the Wi-Fi modem. And essentially this is used to send and receive messages from the driver's station to the RoboRio. Not only we use it for messaging, but we use it to send software down. This particular radio is the only one allowed for FIRST Robotics. And again, this will be continued to be used for the next few years. It has some very, very specialized firmware in it, designed for FIRST, that prevents people from, let's say, hogging too much bandwidth in a competitive environment. the sad thing about it is you can't access the parameters of the Wi-Fi modem. So you must live with the software that they provide, but it does provide some pretty good connectivity when it works correctly. It also supports power over Ethernet, PoE, which you can use then to power things like control the cameras. That's right. Okay, and again, it's powered from 12 volts. So again, a very, very important element of the robot. But again, it's very specific to FRC, and you can't really do anything unique with it. All right, so now we've gone through the basic elements. Now let's talk a little bit about some of the different kinds of motor controllers that we have. The first controller we have, and the one we use most often, is the Talon SRX. And again, this allows software in the RoboRio to control motors. Okay, the power on the Talon is provided again by the red and black wires. Again, red and black must be connected correctly. If they're connected backwards, again, you will wipe it out. And again, it's also a fairly expensive tool, so you don't want to connect it backwards because it will not work. And the cost can be up to 90 bucks for those. The red and black wires, like I said, connect to the battery. The green and yellow wires are connected to the CAN bus, and the green and black, or the green and white wires are connected to the motor that you're going to control. Okay, and finally, there's a connection here for things like encoders and limit switches. So we've used encoders in the robot, for example, to find out how fast the motor is spinning or what position the motor is in. So you'll have a special cable that goes in here. It's called a ribbon cable. And then that will be wired up to either an encoder and or limit switches that we use. Okay. And so basically that's it. And so here again, it shows how you connect up the CAN bus. Like I said, CAN bus is a serial bus that connects, I mean, a bunch of units connected in series. And you connect the H terminal to the H terminal on the RoboRio, and the L terminal or the low terminal to the other one. They support different kinds of encoders. There is numerous things you can do to control it. For example, you can limit the amount of current that the Talon will provide to a motor. You can make the motor go forward, backwards, pretty much at any speed. You can do something called brake mode, which essentially shorts the green and white wires together, so the motor will stop fairly quickly. You can specify peak currents forward and backwards. You have something in there called motion profile that allows you to send a stream of information to the Talon to allow it to control how the motors will turn over time. We've never gotten that to work very well, but luckily we haven't had to use it. Okay, but you can do a tremendous amount of things with the API. And again, there's a lot of software that runs inside here. But the point is that software is provided by the company that designed the Talon. So we don't have to change that software. But what we have to do is we have to parameterize it and tell the software what we want that particular motor that's connected up to that Talon to do. Okay. And in fact, you can even get some digital I/O with it. And it has inside of it something called PIDs that allow you to control either how fast the motor goes or at what position the motor is. And basically with the PID, we use that in things like the elevators and arms, and to control how fast and at what position they stop at. It's got a aluminum case that keeps it fairly cool, and so you don't need fans for it. It's completely sealed, so it shouldn't get any debris inside. And it's electrically isolated, so there's no connections from the wires to the frame of the unit. And then you have an LED on it that blinks, that allows you to see the status. And there's different kinds of indicators that show up on the LED, like you can tell if it's in what's called brake mode or coast mode. And you can change that mode if you want, but rarely we do that. We usually control brake and coast with the software. And so, for example, again, here's some software that we use to go and control the motor. We always start out by allocating an object to control that motor. Then when we want to, for example, initialize the Talon to get all of the parameters set to the factory defaults, we can do that. And then we can go through and start setting different kinds of values in here. This is kind of nebulous, but we could use this to set the position of the quadrature encoder to 0 if we wanted to. Or you could put any number in there, which we use sometimes. You can get the firmware, i.e. the firmware that's loaded into the Talon. You can get the voltage that the Talon is seeing. Not only you can get the voltage on the motor side, but you can also get the voltage on the power side. And you can get the amount of current that the motor is, that the Talon is providing. So you can use it to make some very sophisticated debugging. So you can use it to get the quadrature position, i.e. where the motor is sitting. And here you can set the motor to either brake mode or coast mode. And again, these are very high level things that you can do. But if you go to here, you can go into all of the different kinds of things you can do to the motor. And this isn't exactly what I wanted. But you can control different kinds of safety factors. Okay, like for example, if the motor doesn't get the information after in a certain period of time, you can get the motor will shut off. You can let's see here, we're getting, you can disable the controller, you can get the speed of the motor, you can tell it to invert. So whatever, if you tell it to go forward by setting the inverted, you can get it to go backwards. To set the speed, you set speed. So there's numerous things you can do. And what we've tried to do is we've tried to create a higher level class that kind of isolates this. So basically in the software, all you really need to do, the higher level software, is just do things like set speed, set position, check for the limit switches, so you don't have to usually go into this. But I've tried to make it so we don't have to learn all this stuff to make it a little bit simpler. But there's a ton of stuff you can do with it. There's another kind of motor, the Talon, typically we use this to control different kinds of motors like sim motors and the red motors. But last year we started to use this particular motor. It's called a brushless motor, but it looks exactly like a Talon. In fact, there's an SRX Talon functionality built into this motor, as well as an encoder, as well as provisions for reading limit switches. So essentially, the beauty of this is with one motor, you can replace the encoder and the talon, and you can go and control robot functions. And again, it's a very powerful motor. It's much more powerful than the sim motors or the mini sims. And in fact, it's even more powerful than the red motors. So pretty much this motor here is powerful, almost twice as powerful as the red motors that we've used sometimes. So if you remember, we used one of these motors this year to lift the robot, and it was more than powerful enough to lift the robot. So again, it's very efficient, and it's a very, very nice motor. And over the next year or so, I want to use more and more of these motors in the robot because it's much, much simpler to use. And again, if you can see up here, you got the power leads again, the red and the black. And then you got the CAN bus, red, yellow, and green wires. So it's very simple to use. Okay, another kind of motor controller that we've used in the past. And in fact, the robot, the big robot, the wheels are controlled by this motor this year. And again, it's used very similar to the Talon, but the Talon's used for brushed motors, and this is used for brushless motors. And again, fairly similar to the Talon, but it's got a different software interface. But again, I've tried to make a class that helps us isolate that. So we don't really have to worry about the differences between the Talon and the Spark. But again, brushless motors tend to be more efficient than what's called brush motors. And so examples of the brush motors are the Neo brushless motors and the Neo 550s, which we use on this year robot for the drive system. And then we could use the sim motors as well, but we've never used sim motors on the Spark Max. Okay. All right. Another thing we use is a lidar. Again, this is very key that are a very interesting part that we use to measure distances. And again, it uses a laser beam. It shines a laser beam out one of these. And then on the other side, it detects that laser beam coming back. It's fairly accurate. It can be accurate up to 2.5 centimeters. And again, we use the I2C interface to read from it. Okay, we've created a very specialized wiring harness that basically you can plug it into here, the connection for it, and the other end we connect up to the I2C port on the RoboReel. Okay, another kind of sensor we use is an ultrasonic sensor. It can also be fairly accurate, but it's not, I don't know if I believe that, but it can't read long distances. So I forget what it is. It says it can go to 300 inches. Okay, and there's different kinds of sensors of this nature. You can order different kinds that have different kinds of characteristics. Let me see if this shows them. Yeah, so there's different ones with different beam widths. So you can get a narrow beam, a wider beam, and a very wide beam. And so you can use different kinds of sensors depending on what your application is. Okay. So for example, we've used these kinds of sensors to sense when the robot is nearing a wall. So one of the things we have in Drive Straight, for example, is I want to drive to within 12 inches of a wall. And we would use this type of sensor to detect that function. Okay, these are another kind of sensor we used. These connect to the analog port on the Robo Rio. And again, there's 3 wires, a power, a ground, and a signal wire. Okay. And basically we use these for very short distances. Like we use these to tell when, for example, on the robot this year, when a ball is in the getting ready in the hopper, ready to go into the magazine. So we use these for short distances, but they again use an infrared kind of technique where one of these is a sender and one of these is a receiver. Okay. All right, another thing very important, like and we're getting in real quick now, just a couple more slides left. It's very important that we use the correct wire gauge. And so we use very thick wire. The lower number on the gauge, the thicker the wire is. So we use that for batteries and the wires to the PDF or the power distribution panel. We use 12 gauge for motors and motor controllers. We use 18 gauge wire for air compressors, things like the PCM and the VRM. And then we use 22 gauge for controlling things like the pneumatic solenoids, the pneumatic switches, and different kinds of sensors. They don't require much current, so we can use a much, much smaller wire. Okay, so this is very important for those who are going to help wire up the robot. We want to have a standard. And so the standard we've kind of selected is documented on this slide. For example, for the CAN bus, we use what's called 2-wire JST connectors. So we can plug and unplug elements from the CAN bus very quickly. We use these connectors for things that require a lot of power, like the LED rings. We've also used these connectors for devices that require 12 volts. We use these terminal lugs for motor connectors. And finally, we use these 3-wire JST connectors for the sensors we've talked about, like the distance sensors and the ultrasonic sensors. Again, they have 3 wires in it. So again, we also have a standard that the female side of the terminal lugs is on the source of the power, i.e. where the power comes from, and the male lug is on the user of the power. So as long as you use that convention, we can plug and unplug elements very quickly. If something breaks in the field and doesn't work right, we can very easily disconnect the motor wires and the CAN wires, and that unit is replaced. Okay. Again, very important. Red is for positive voltage, black is for ground wires, yellow and green are for the CAN bus, and white we typically use for sensors. Okay, and again, like I said, oops, your wire gauge is very, very important. Okay, and another thing when we go through wiring, we want to use common sense wherever possible. We want to keep the wire runs as short as possible. Okay, not so short that the wires are stretched, but short enough that they don't waste a lot of distance, because some of the wires, especially motor wires, the longer they are, the more loss they have and the less effective they are. Again, make sure all connections are good, i.e. metal touches metal, nothing gets in the way, no plastic. We use zip ties to hold the wires in place. We use these things down here, in particular, these things called ferrules. We use those when we connect up to the connectors on the power distribution panel. So we use the bigger ones that typically are green or yellow for these kind of things. And then we use these small red ones when we connect up to things like the connections on, like for example, these kind of connectors, we use red ferrules. And again, when you wire up a ferrule, you got to make sure it's a good connection, because we've had a lot of ferrules that if they're not done correctly, they'll come out. So when we have some classes, when we start coming back into the robot, we'll talk about how to connect up ferrules so they don't come out. And as long as you connect them correctly and they work good, they will not come out. And again, wherever possible, we use heat shrink to insulate wires. And again, you got to remember to place the heat shrink on before you solder or crimp the wires, because once you've crimped ends on wires, it's very hard to put the heat shrink on. So you have to take the crimp off, and that's not good. And wherever possible, we want to try to label the wires. We have not done a good job of that in the past, but we got a nice device that allows us to wire, or a nice label maker for wires in particular. So we'll try to use that next year. And again, avoid the use of black tape if possible. It's messy and does not work very well. And again, in soldering class, we're going to learn the proper splicing and soldering techniques that we will use when we're building up cables. And again, we got to ensure that the wiring is not in contact with any of the moving parts of the robot. So that's where we use tie wraps or whatever to keep that done. I think this is the last slide. And again, it's very messy, but again, it talks about everything we learned in the meeting today. So here we're showing connecting the radio. And again, that has basically a couple different wires to it. We can either use PoE to power it, okay, via this method, or we can physically connect it. Okay, so basically let's start over here. They don't show the battery, but we do show, well, I guess we do show the battery. So this goes to the battery. So the positive lead of the battery goes into the circuit breaker, which in turn goes into the power distribution panel. The negative wire from the battery connects directly to the power distribution panel. Then the motor controllers use, again, the thicker wire to connect those. And if there's any kind of digital inputs we need, well, okay, we don't use these very often. But this here is a special kind of robot motor controller that we don't use very often, but you need to use that PWM to control that. But the kinds of motor controllers we do use are these, like the Sparks and the Talons. And again, you can see, again, through the power distribution panel, you connect the high power leads to those so we can power the high powered motors. You can also connect motors to the low power connections, but those are motors that aren't going to be under a lot of stress and force. You can see the CAN bus, it's shown here wired up. It starts out at the it starts out over here at the CAN bus. The RoboRio goes into the pneumatic control modules. Then we'll in turn go to every kind of motor controller that we have. And then finally it terminates on the power distribution panel. Turns out here we're showing the connections to the compressor from the PCM and the connection from the power switch to the PCM. Okay, and here it shows again how to connect a pneumatic solenoid. Again, you see the solenoid, we've got the two types of solenoids, the double type solenoids and the single type solenoids. Most of the time we use double solenoids that allow us to push in or push out. Okay, Let's see what else we got here. And then here's the robot signal. Got the robot signal. No. I guess this shows if we want to connect up any kind of digital devices we can here. Oh, here's the robot signal light. Okay, so here's a switch if we want to connect it up and read the value of that switch from the digital I/O. And finally, we connect up servos here to the PWM wires. So in an overview, that is how you wire up a robot. So we went through a lot of material very quickly, but this presentation, anybody who's going to do wiring of the robot this year should be very familiar and comfortable with this. You don't want fuses to blow unless there's a real serious problem in the robot. Okay. All right. So thanks for your attention. And I think we're done.